start. So basically, we said we are going to talk about the last big topic in this course, okay, which is actually authentication. Okay. Well, that's the outline. So basically, authentication. Who are you? Okay. So I mean, you use a web application. They tell you who are you. You need to provide some credentials, typically username and password or something like this. And so the application recognizes you as a specific user, and you can act inside the data of your application on the data on which you are authorized to work. Okay, so actually first, before going on and discuss all the authorization, how to implement it in web application issues and so on, understanding the difference between authentication and authorization, that's really important, especially in this course of cybersecurity. Okay, authentication is about verify that you are who you say you are. So it's about an identity. It's about identity. So when you go to the airport, you need to provide an ID, okay, to board the plane. You need to provide that you are who you claim you are. Okay, the authorization is the boarding pass. Okay, so it's what this person, okay, you is authorized to do. It can board this plane and not the other one. Okay, so authentication is typically done with credentials in web application, username and password. Okay, at least that's a typical way that has been used until, let's say, now. Okay. But I mean, basically that's the way, even with modern system, passkey and so on. I mean, just hidden from the user, but it's basically you need to say I'm a certain person, I'm a certain user, and this is the way in which I prove it with the password, with the secret content that I provide to the server. Okay, of course, allows a personalized user experience. It means that the application shows you something which is just for you. Okay, I mean, but I think we all experience this this behavior. I mean, with a web application shows your email because you provide your username and password, or just your booking in a plane and a theater and so on, or when you buy online, etc. Okay, authorization instead is the process to decide if you have permission to do something, typically to access resources. Okay, and typically the authorization you have depends on the identity. Okay, some users can do something like I can upload material on the GitHub of the web course, and you cannot. You can just read the stuff. I can read but also write. Okay, so my authorization, okay, on that resource, the GitHub, is different from yours. Often used in conjunction, okay, to protect access to the system, of course. And I mean, this is the most complicated topic in the course, and that's why it comes at the end. But I mean, not only because it's also good in learning, because it's the last important thing we really need to learn to create web applications, and it involves both client and the server. So that's a good clue why it comes here, because at this point we have a good idea what the client is doing, what the server is doing. It requires a lot of new concept, but I mean, in general, try to rely on best practice, standardized process, and so on. Try not to invent anything about authentication and authorization. So easy to get things wrong that it's not worth the trouble. Okay, even for your future work life. Okay, you really need to be an expert, and typically expert design things together. It's not just one that comes out and say, well, that's the way in which we will do things, and everybody is happy and so on. They want to test, make sure, I mean, to experiment and so on. Okay? Okay, many layers of authorization. I mean, there are many points in which many actors are involved in doing things in a certain way at a certain moment and so on. I think you can read this slide. I mean, just for a reference, just to show you how complex these operations can be. Okay? The React app needs to know if the user is logged in. The browser needs to remember the session. We will talk about the session in a few minutes. The server again need to remember the session. You need to check the authorizations on the server. You need to forget about authentication when you do the logout and so on. So many things need to happen to make everything work. You need to have a list of users in the database with their password and so on. Okay? So many things to do. Okay, so let's start with the simplest concept. Giving memory to HTTP, so the cookies and the session. So you know that HTTP in its basic form is stateless. You make a request and you get a response, as we did until now. Okay? Any request is independent of the other requests. You make a request, everything is contained in the request, and you get a response. I ask for the list of things and so I get a response. But sometimes, I would say often, almost always in actual real applications, you need to remember things, so keep some information between different interactions with the server. Okay, I just authenticated, the server needs to remember it's me, and so it shows me my email, my bookings, and so on. Okay, online shop, in the shopping cart, etc. Okay, many examples. Basically, every website nowadays, except websites that provide public information, so they don't really care who you are to show you information. Okay, so this leads us to the concept of the session. A session, okay, is a temporary interactive data exchanged between two or more parties. Devices, okay, typically two computers, the server one and the client one. Okay, involves one or more messages in each direction. So it can a session can include many exchanges between client and server, and one of the parties typically keep the state of the application. Okay, state in the sense of actual state of the meaning of the English word. Okay, state of the application. So not a React state. Okay, it is established at a certain point in time. It means typically when you perform the authentication, you establish a session because the server wants to establish a session. Okay, at a certain point you can even end it. Either you end it with an explicit action, click on logout, exit, and so on. Or because of some timeout, at a certain time the session will end. Okay. A session ID is the basic mechanism that we have in HTTP to maintain a session. Okay. So once you decide you want to establish a session, you make sure that who makes the request can establish a session. The server will create a session ID that will be sent back to the client, and the session ID will allow the server to recognize a subsequent HTTP request and attach them to the same session, authenticated session actually. Okay, and to make everything work, it means that this ID, which is basically a secret sort of string of some bytes, must be stored on the client side because I need to resend it every time I make a new request to make the server recognize the request belongs to a certain session. And also because it's stored on the client, it must not contain sensitive data because in general, it's easy to see what's the data stored in the client. We just saw it before. That's the inspector and so on. You can look in the content of the disk and so on. So it should not store sensitive information. So in short, just to give you a very trivial example, the session ID cannot be the password. Okay? Of course, it will work. Okay? Password plus something else. But if I read this session ID, I see the password, I can create another one. Okay? So I don't like this situation. It should be some identifier which is opaque. I cannot see what's written inside the ID if something is written inside. And of course, it must be protected from eavesdropping, so wiretapping, if you like, during communication. So it shouldn't be possible to intercept and read this value while it goes from the client to the server and vice versa, because otherwise, if I have this ID, I can send requests, pretend to send requests to the server as if I were part of the same session, which I'm not, okay? Because I didn't authenticate, I just took the ID, okay? And to end this long story, this session is typically stored in the client in the form of a cookie. Cookie means, you know, the meaning of the English word. It's, you know, something you can eat. But it means a very short piece of information. I mean, a few bytes. I mean, in the order of hundreds or maximum 1,000, something like this. Okay, and it needs to be sent every time you make a request to make the server recognize the request belongs to a certain session. Okay. So what is a cookie? Actually, a cookie is not something really abstract. It has been standardized in an RFC. Okay. It's a small portion of information inserted in HTTP headers, and it has a certain format, a certain allowed values, and so on. And the nice thing for us, at least for this course in web applications, is that it's automatically handled by the browser. So if the server stores a cookie in the client, the browser takes care of managing the cookie. So the only thing we will need to care about is to create this cookie on the server side, okay? And decide which are the parameters and so on of the cookie. Even though, I mean, we will have a library to do it, so it's even easy. It's easy to do this also for the server side. And the important thing is to remember that the cookie is automatically sent by the browser to the server when performing a request to the same domain and path that originally sent the cookie. Let's say I just access didactica.polito.it/exams. Okay, so the page in your Polito web application where you see the exam. It set a cookie because first, before showing me information, it asked me for username and password. It sets a cookie in the browser, and then next request, so clicking details of the exam, filtering the list, and so on, everything is requested to the server, and when you do the request, the browser automatically sends the cookie to that server, but only to that server, because it has the same domain and path, okay, that is the one that originally set the cookie. So if I access bank.com, gmail.com, and so on, the browser keeps the cookie for itself, and it does not send the cookie, of course. Not that cookie. It will maybe send another one that was set from the other website. Note, be careful. I mean, the port is not included, okay? So just domain and path, okay? Never store sensitive information in a cookie. So as I was saying before, you cannot store passwords, at least not in clear text, secrets, and so on, because you saw it before, right? So I mean, we can play here. There's a storage. What is this storage stuff? There's plenty of cookie right here. I mean, the stuff not really important. It's on localhost, so just tests and stuff like that. But I mean, you can read it on the client. Okay, so just don't store anything meaningful that can be used by somebody looking at the value. Okay, the cookie the cookie is made of some attributes which are set by the server. 2 are mandatory, so it means you need to set them compulsorily when you decide to create a new cookie. Of course, the name and the value. So each cookie has a name and a value that you need to decide. I mean, like the name could be session ID, PHP session, whatever you want, okay? It doesn't have to be unique for the whole websites in the world, just for your website, because you can create more than one cookie, okay? So that's why you need to give a name to each one of the cookies you create. And then, of course, a value. And then there are 3 important attributes. One is the secure attribute, which is actually a Boolean attribute. If set, the cookie will be sent by the server, will be sent to the server, so by the client, by the browser to the server, only if using HTTPS connections. So the encrypted and secured connections. Okay. So in short, the browser will make sure it will never send it on a non-encrypted communication channel. HTTP only, that's another very important attribute that we will use in this course. If said, the cookie will be inaccessible to JavaScript code running in the browser. Actually, this might seem strange, but actually we don't need to access the cookie from our JavaScript code because it's already handled automatically by the browser. When we make request and there's a cookie to be sent to the server, the browser can send it automatically. I mean, letting the cookie, allowing the cookie to be accessed by the JavaScript in the browser just expose the cookie to a lot of potential vulnerabilities. Because if somebody manages to insert some JavaScript code, malicious JavaScript code in our web application, it can read the cookie and can send it to her servers and use it for, unwanted and operations, like pretending to be us, I mean, being like us that we authenticated before and send the request as they were authenticated. Okay, because the server, the only way the server has to check if the request has been authenticated before is to look for the value of this session ID. Okay, and if it recognizes the session ID, it assumes that it comes from a client that was previously authenticated on the server. Okay, with the server. And then, of course, there's an expiration date because any information that relates to security is, I mean, at a certain time should expire. I mean, at least in general, as a general principle. Okay. Even though, I mean, sometimes we, like in this, in the examples we will do in the course, I mean, we'll not set an explicit expiration, but when you close the browser, the cookie will simply be forgotten. Okay, so the browser does not store it permanently. But if you store something permanently, maybe it's better to give an expiration date. Okay, so that's the way in which the authentication operation operates. So we want to create a session that's a browser that initiates a request toward the server without having any cookie. So the first thing it does is it sends a username and password. Okay, so two values, we call them credentials, toward the server, and the server will check if they correspond to somebody that has the possibility to authenticate on its system. Okay, if yes, it will answer with a cookie that will contain some information, the value of the cookie, name and value of the cookie. Okay, and then next request by the browser will automatically include this cookie. And so the server will always check for each request if a cookie was inserted. If a cookie is inserted, it will look up the user that performed the authentication before. It will check the authorization of the user, and if everything is fine, it will give an answer to the request, providing the information that was required. Okay? I mean, if the request does not require to be authenticated, it doesn't matter. Just answer without checking the session ID. If the request requires authentication, we'll check the session ID, we'll check the user, and we'll check if the user is authorized. Okay? Okay, typically this cookie is stored, sorry, not the cookie, the cookie we already said is stored in the browser. The information associated with the session is stored in the server. So typically, we call it the user state. I mean, the information that was set up at the beginning of the session, and that can later update it during the session as well. Okay, so there's a certain set of properties that we can associate with the session. Typically, the most important property is which user authenticated on this session. Okay, was authenticated in this session. So, like a username of the user, which is a typical unique ID of the user, and it might contain. I mean, the session on the server may contain other information, like I don't know, first name, last name, address, authorization levels, is an administrator, and so on. Anything that might be useful in your application. But the really basic information is who is the user. So we need a unique user ID associated to the session. Okay. Typically, in good service, it's saved somewhere in the database on the file system, and we don't really care. I mean, just for our experimentations in this course, we will save it in memory only because it's easier. Okay, so it means also that when you restart the server in our simple tests, basically you lose all the session information. So users have to be need to authenticate again. Okay, but in more serious servers, let's say, they are stored permanently in some permanent storage, database, file system, and so on. So if they have to restart the server, you typically don't have to re-authenticate. Okay, but this is just a detail. Okay. What happens in case I make a request and the cookie is not valid, so the value doesn't correspond to an active session? Well, the server simply answers with a different HTTP status code. That's a typical status code 401 unauthorized. Okay, I cannot answer. That's all. Okay. So always use HTTPS and the secure option in cookies, at least when you develop real world applications. And also always use the HTTP only option in cookies. In our application, there's no reasons why JavaScript should be able to access these cookies. Okay? Because they are automatically managed by the browser. We don't really need to know, not even the value of the cookie. Okay? If we need to know if a session was established or not, we cannot just go and look if there's a cookie or not, because we say it's inaccessible from JavaScript. We just ask the server. We send a request to the server. If the server sees the cookie, it will answer with some information related to the cookie which is authenticated. Otherwise, we say unauthorized. That's fine. Okay, we understand we have no session established. Fine. Never store sensitive information in cookies. And then, okay, that's the theory. In practice, I mean, just for this course, just because for configuration simplicity and so on, just because setting up HTTPS and working with the browser without warning and so on is so difficult, so complex, and we don't really care. I mean, for developing web applications, actually, we say that the theory is like this. We will ignore, okay, the HTTPS. Indeed, what we tested until now was just HTTP, so unencrypted channels. Okay, we know. I mean, we know it's not the best from the theoretical point of view, but just for debugging and testing, that's more than enough. Okay. Also, there's no real difference for testing the application on HTTP versus HTTPS. The only difference is that the channel is encrypted, okay? But apart from that, the interactions are exactly the same, okay? Just the URL includes the schema, which is different, HTTPS instead of HTTP, but that's the only difference, Okay, so it doesn't make any difference for us just testing things on HTTP. Of course, when you have a real application, you will use HTTPS. But you know, HTTPS requires you to set up a certificate on the server side. Either it is self-signed, so it gives you a lot of warnings in the browser, or you buy something, but you need to have a domain name which is not localhost and so on. So it creates a lot of problems to us, and it gives us no benefit. So that's why we will only use HTTP. But you know, we know that once we finish with our application, everything is ready to be put into production. So it means be used by actual users. We need to set up HTTPS. Okay, but usually it's not that difficult. Okay, it's more an issue of from the point of view of system developers and system administrators rather than application developers. So it's not even our duty, say, to set up the HTTPS. So again, rely on best practice. Don't reinvent the wheel, as we say, because there are so many attacks that can be that our web application face nowadays. So I mean, just try to stick to developed frameworks, best practices, and so on. So just to give you an example of the possible attacks, we will repeat this many times. You know, the cross-site scripting. We already saw the cross-site scripting a few weeks ago. You have malicious JavaScript code inserted into your web pages. We just saw the alert. Okay, so I just open the alert. But that was just an example. You know, this kind of attacks exist and actually are present in the world. I mean, can be just a post somewhere in some forum and so on. I mean, try, to adopt the best security practices to avoid as much as possible, we say mitigate as much as possible these problems. Like HTTP only, use this option because it's really something that can help you. I mean, the browser doesn't allow JavaScript to access the cookies, so nobody can steal your cookie through JavaScript because not even you can access the cookie. Okay. For instance, another issue is the CSRF, cross-site request forgery. So, like when you get a link, and in general, the user get a link with in some ways, through an email, WhatsApp message, or whatever, and it's tricked into clicking on the link. Okay, you have an authenticated session in another tab in the browser, and this link refers to that site. We saw last time what happens. I mean, the cookie information in this case, so the session ID goes to the server, and the server recognizes the request as an authentic, belonging to a session that actually exists. Okay, and we cannot do anything about this because if we stop sending cookies, the server will think we are not authenticated. And if we have no access to the cookie, the browser has to send the cookie every time it makes a request. Okay, so we will see in the end of the course a possible mitigation strategy. So requesting a second form of authorization. Okay. Next week, I think. No, the last. Yeah, next week. Second part of next week. But actually, there's no real solution for preventing the CSRF. I mean, there are solutions, but they are constantly being challenged by the attackers because any cross-site scripting attack can, in principle, defeat any solution that tries to avoid the cross-site request forgery because it's basically some JavaScript and sending additional data through JavaScript and so on. Okay. Anyway, trying to stick to best practices, best frameworks, and so on may already prevent a lot of attacks. Okay. So that's the advice, and now we will see what to do in practice. Again, we need to implement all these nice concepts in something very practical in our web application. So we have a passport.js, we have React, and so let's decide what to do. You know what happens when you do authentication. So at a certain point, you have a page, that's a username and password field. I mean, either the same page, one page after the other. Let's take the example of single page, which is easier. Okay, we have one less page to program. So a user fills out a form in which a client with a unique user identifier, so a username and a password. So it provides this username and a password, and then you send the information to the server with the POST API. Remember, this is always a POST API. You don't have to invent anything, okay? It's a POST API because it's something that gives you establish a session on the server. So change the state of the server. It's not the same if you post it once or twice. You get two different answers, okay? Two different sessions IDs. And by the way, the post also doesn't show the content of the request directly on the URL like the GET, but this is just a consideration. I mean, we need to use a post because actually we change the state on the server. The server receives the request, checks if the password corresponds to the username. Actually, it also checks if the username exists. And we will see how this works. And if something goes wrong, it just says no authentication has been performed. Okay? So the typical message is invalid user ID or password, invalid username or password. Please don't invent any other message and don't distinguish between any other cases on the server. Okay? This is wrong. Okay, you see it's red, right? Because you don't want to give attackers additional information. You cannot answer login for user foo invalid password because this leaks information. It says the user foo exists. Okay? You try the admin and just a random password. Admin cannot log in. I mean, it's not a good answer because it says, okay, the name of the admin is probably admin. Okay? Or login failed, invalid user ID, or account disabled, or whatever you think. I mean, just don't think. Just answer incorrect username or password. As, most of the websites do, because that's the best thing to do. Don't give away any information. Okay? So, we don't want to tell anybody if the user actually exists or not. Okay? Or any state of the account and so on. Okay? So really easy. This stuff will be provided to you, let's say, at no cost. There will be an example. I will show you an example. Next time we will program together an example. We will write some code. And so this page basically is almost the same. Okay, there's always two fields, username and password. Maybe you want to use a normal username or an email and so on. You need to change a little bit, to force the user to be an email before sending it because, I don't know, for some reason we want to use an email. So, just a little bit of checking on the client, but just for convenience. This is just convenience. It doesn't really matter with the concept of authentication that we are going to see here. And then what happens in case everything is fine? So username and password are correct. The server creates a new session ID, which is associated only with that username. Okay. The server stores the session ID, ideally in some permanent place, but in our application, just for convenience, just in memory. And it stores this session ID, and it also has the possibility to attach some information which is kept in the server together with the session ID. Okay? We will come back to this later. The server then replies to the client because it has to give an answer to the HTTP request. So it will answer with 200 OK, so everything went OK. And there's a special header in HTTP that allows the server communicate to the client that it must set a new cookie. Okay? Of course, it needs to communicate the property that we saw before. So what's the name of the cookie? What's the value of the cookie? This session ID that has been just generated. And the properties, especially the property we don't want to have them at the default value, like HTTP only, true. secure true in case we want to use HTTPS. We will not set it, but I mean, in general, you need to set it. Okay. And then the browser receives the response with the cookie. The cookie is recognized by the browser because the browser reads the headers of the HTTP response and it stores the cookie information in its own storage. I showed it to you before. Right? So that's the storage information for the cookie. See, storage, depending on the website. Actually, I have just one website here. Okay, and this is name and value, HTTP only and secure. Okay, good. And the response body, the rest of the response body is handled by the web application. As usual, it's a normal response. So if you want to communicate some data, typically you want to communicate some data. You want to send some user information like first name, last name, and so on. Welcome, Enrico. Okay, after authentication, of course, because otherwise, welcome, Antonio, welcome, whatever. Okay. So the response body is a normal response body. You can decode it from the application as in any normal HTTP request. Okay, so practice. In practice, client. Very simple. The client is probably the easiest thing to program. You just need a new page. But now we have done plenty of pages. So a form, a controlled form component. So it's React. Let's create a new component, login form. It has two states, two fields, username and password. Initially empty, or initially you can put something for your convenience, just for testing, like a default username and password, just for testing for you. So you don't have to type everything every time, just when you're practicing and developing. And then you will have a form. So return some JSX. Form, input type text, input type password. So if you have the input type password, when you type, there are the asterisk or the dots and so on, automatically. And then when the user clicks on submit, or the user clicks on some button that says, okay, go ahead with the authentication, you have a callback that is being called with some event. Okay, if it's a submit, don't forget to do the prevent default, so you don't reload the page. Okay, so if you reload the application, of course that's bad, as we said until now. And you can do basic checks, like if there are empty fields. I mean, there's no point in sending empty fields to the server, because for sure it will not give us any session, right? Because there's nothing it can check. But I mean, you can check if the username is an email, in case if you know an email is needed. Okay, just to save some useless communication with the server. Okay, but I would not do anything more, because the more you do in the client, the more the attacker can learn from your website. I mean, you don't need to check if, let's say, the username is actually an email that has a dot in the middle, enrico.mazala, or whatever else. Say the password is already at least n characters length and so on. Okay, don't do anything special apart from the obvious things. I mean, empty fields are useless, of course. Okay, and then you have an API to call, like we did before. It's a post. So there will be an additional API on the client, so a file that contains a function that returns a promise and does a fetch with the method post on a certain URL. Okay, we will see which one. And of course, in the body, you need to communicate both username and the password, because the server has to check them. Okay, so really simple. That's a client. We basically finished the client. The really difficult part is the server, of course. So what are we going to do on the server? Well, of course, we are not writing things from scratch, because it takes so much time, and as we said before, it's so error prone, and I mean, we try to use as much as possible libraries, framework, and so on. So I will give you some advice on what to do. So there is a library that works well with our server system, which is now based on Node and JavaScript, that is named Passport. Okay, it's very flexible, modular. I mean, it could be documented a bit better, but I mean, that's what we have at the moment. But at least supports many different authentication strategies. Of course, the really basic stuff like username and password, but you know that nowadays you can log in through other systems like requesting information to other well-known websites where typically users have already some login information like Google, Meta, etc., etc. I mean, it supports a lot of authentication methods. Okay, it can adapt easily to different types of database and adopt. That's good for us. Some best practices under the hood means without the need of configuring anything differently from the default configuration. Okay, for instance, it uses actually cookies. We say nothing, it uses HTTP only cookies. That is good for us. Okay, because that's what we want. We don't want the JavaScript be able to access the cookies on the client side. Okay, so very easy to install, npm install passport. And then we need to do a bit of configuration, which is the most difficult and I would say annoying part. Okay, but once you do it, you just copy and paste. I mean, there's really nothing you need to do differently here. So a server based on Express, that is the library that we are using for the server that basically handles the HTTP communication, needs to be configured in 3 different ways for 3 different let's say characteristics, and we will see them in the next slides. So first, we choose which authentication strategy we need to adopt, and the authentication strategy is this local strategy, which comes with this package passport local, and it's basically another name to say we will use a username and password. Okay, so we don't rely on third-party websites and so on to do the authentication. Okay, and we need to basically implement a function which is called verify that takes 3 parameters. 2 are the obvious one, username and password. Okay, and the third is a callback to be called in a certain way depending on the outcome of what we found with username and password, because it's up to us to decide if username and password are okay for letting the user in or not. So we need to write some code to store username and password and check if username and password correspond to something we have in a database. That's our task, okay? Because it depends on the database, depends on how we wanted to store the information in the server and so on, okay? So that's why the authentication strategy ask us to write this callback, which has this signature, username, password, and callback. Okay. This is an example of what we can write. Like the DAO, I mean, we go to the database, we get the information from a certain username, so there will be a query like select from users, the table users, where username equal to the one that is being provided. We get in the information about the user, especially the password. Then we will compare the password. We'll come back to the password in a minute, but we will compare the password. The 2 password matches. I mean, the 2 password match. It's fine. Okay. So then, and this is implemented as a promise. So with the then, in short, we say, okay, everything is fine, and we call this callback that will take will tell the local strategy everything went fine. So you can authenticate the user. Do everything else that you are supposed to do. Create a session ID, send it back to the user and so on, to the client and so on. Okay? If not, I mean, just call the callback in a different way, like with false and so on. We will see an example. And optionally provide a message. And remember, this message always needs to be very generic, incorrect username and or password. We don't want to leak any information. Of course, we know if the user exists or not. We know if the match was wrong on the password, but the user exists and so on. We don't want to say this. to the client. Why? Because we don't know who is doing the request. Could be an actual user, it's just mistyped the password. Could be somebody else on the other side of the world sending a request for authentication. Okay, we don't really want to give information away if it can be a risk. Okay, as in this case, we don't know who is doing the request. Okay, so actually, the way in which the callback works is written here on the slide. So in short, we call it with null, comma user, some user information that will be stored directly by password inside the session, so kept in the memory together with the session ID. And that's a normal way of proceeding when we have a match with the password and the user exists. So everything is fine. We are able to authenticate the user. Otherwise, there are other options. Okay, so null, false, we eventually, potentially with the message. Or if there is an application, you can call it also in another way. But doesn't really matter that much to the user. Yeah, you can communicate this condition to the user just to tell the user, well, actually, it's not your fault. We have the database is not working now. Try again later. Okay, that's the difference between these two cases. Okay. Otherwise, of course, you type your username and password. You're sure they work, and the user does not log in, and so the server says it doesn't work. I don't give you a session. It would be nice for the user to know, okay, if there is some issue in the database, or regardless of the fact your stuff is correct or not. I cannot authenticate anybody at the moment, or it's just a matter of username and password. Okay. But I would say this implementation is more than enough. Of course, I will provide you an implementation for next time for Thursday. That will be an example on the GitHub with this strategy implemented. Okay, because there's no real value in implementing things in a different way. Okay, so actually, let's stick to best practices. Just use them. It's fine. Okay, some more words about storing passwords, because of course passwords are sensitive information, something you really need to care a lot about. Okay, never store plain text password in the server. This is a really bad practice. Okay, like in the database and so on. Always perform this operation, which is called hashing, which is not encryption. We'll discuss in a minute. Because if your database, your list of passwords gets stolen, you are in trouble, right? Because basically it means that anybody can log into your system and do operation instead of the actual users. Okay? You know that many passwords are stolen nowadays. Many database with passwords are stolen nowadays. They are sold in this dark web or whatever it is. Okay, with this illegal transaction and so on. But at least try to make the life of the attackers more complicated by not storing password in plain text. You just don't read the database and you see, oh, that's the username and that's the password. Okay, and how can we achieve this goal? Because we need to check on the server if the password matches what has been provided by the user. But if we don't have the password, how can we do it? Well, the solution is this one. It's been in use for more than 20 years, I think. Okay, so do password hashing. It means nobody can read the password even if they get access to the database, because when the password is set, we apply a function that cannot be inverted, okay, and then we store the result in the server. And that is the only thing that we need to remember on the server. When the user comes with his or her password, it will set the password for login. We apply the same hash function. We get the same hash, the same result, and we compare the two results. If they match, the password was the same. If they don't match, the password is not the same. Okay, but in this way, we don't have to store the actual password in the database. We just store an hash, which cannot be reversed. You cannot go back to the password. Okay, not directly. It's not like encryption. Encryption is a symmetric operation. You know the key, you encrypt something, and then with the key, the key for decryption, you decrypt the key. Okay, this is not the way it works. You need to have an hash function. It means that if you don't know what is being hashed, you cannot derive the value from the hash. Okay? Of course, you can try to guess, and that's a different problem. Okay? So if you have a weak password, like 123456, and hello world, whatever, password and so on, it's sort of a problem. Okay? But I mean, this is not a system problem. I mean, you tried to make life difficult for the attackers. Okay, so this is required for the exam, but actually it's also in the examples that we will see. So you need to really put effort if you want to deviate from this behavior. Okay, so just stick to the behavior we propose. But here we want to understand the concept. So good hashing is impossible to crack in the sense that if you use a cryptographically secure hashing functions, it should be difficult enough for cracking. I mean, in practice, impossible. Okay? But the problem is that password can be guessed. So, I mean, you can guess that maybe I can use a simple password like 123456, or maybe password, or just a password with uppercase P, and all this kind of stuff that you put on the website when you don't care that much, right? So, I mean, these dictionary-based attacks are always possible. So if you have a list of hashes, you know the hashing function, because actually the hashing function is inside password, right? So, I mean, anybody knows which hashing function is being used if you're using a certain software. Just try to hash many different passwords, and when you find an hash that is the same, it means you guessed the password. And so for a user, you know that a certain password works. And so you can go to the actual website, log in, and perform operations on the behalf of the attacked user, okay? Of the user for which you cracked the password. Okay, computing the hash is a bit computationally expensive, but when you get a list of hashes, okay, like there has been a database stolen with a list of username and password, if you had no further, let's say you didn't use further, how to say, I mean, you just store the hashes, okay, without adding anything else that we are going to see in the next slide. I mean, the point is that the attacker can do an hash of a password coming from a list of known password, easy password, dictionary password, and so on, and then compute just the hash with all the hashes that are available in the database, okay, in the list. And you see that, for instance, in this very simple example, there are two users, user 3 and user 5, which have the same hash. By the way, this also means that both users use the same password. And by the way, it's typically an indication that it's a weak password. Okay, it's difficult to guess. I mean that different users use two passwords which are actually the same when the password is not easy to guess. Okay, not based on a password in a word in a dictionary and so on. Okay, so the attacker starts from those hashes and it tries to guess the password, starting from the simplest one, you know, Q, W, E, R, T, and so on, all this stuff, which is well known. Okay, there are libraries that can do this. And once you get the same hash, you guess the password, actually even for more users. Okay, think in terms of you know, this is very simple, a small example, but like you stole the table for the users for a big site, I don't know, Yahoo, Google, and so on. There are like 1 billion rows. Okay, so make 1 billion hashes is much more computationally complex than just making an hash and comparing with 1 billion strings. Right, that can be done in seconds. So if you don't adopt any further strategy, I mean, once you get a list of 1 billion hashes, for sure you guess a password quite easily and quite quickly. Okay, so what can you do to prevent, at least, I mean, not really prevent, but mitigate, so reduce the possibility that an attack like this is successful? Well, you add what is called salt, okay, like the one you eat, to the passwords. So a unique randomly generated string added to each password before the hashing process, just concatenated. There's a string and you add something and you do the hash. Salt is unique for every user and it can be stored in clear text. It doesn't need to be hashed. I mean, you cannot actually. It's useless. The system would not work. It's generated, so it's created randomly when you set a new password. And this is little computational complexity for performing the authentication operations when the correct password is provided by the user, but increases the computational complexity of the attack quite a lot. Okay, because in this way the attacker has to try to use the password it wants to guess plus the salt for one time for each of the passwords. Okay, that hashed password that it has. So like there were 1 billion passwords, it has to do 1 billion hashes to compare password plus salt for each one of the hashes it has. Okay? Most of the modern hashing algorithms automatically add the salt to the password. Not ours, unfortunately, but I mean, it's so easy to write, so it doesn't really well, no, maybe the algorithm, yes, but we need to store the salt explicitly in the database. So we go from the previous situation to this situation where you have still, I mean, maybe there are users that have the same password, weak password, but you don't know which one they are, because even if they have the same password, which we said before, it's typically an indication of a weak password. I mean, the hash is different because they have a different salt. The salt is different for each one of the users. Okay, so let's say you want to start trying 1, 2, 3, 4, 5, 6. You need to hash it with the salt number 1, number 2, number 3, number 4. So instead of doing one hash operation, which is a bit computationally complex, not too much because you need it for authenticating users, but you know, it takes a little bit of time. Multiplied by 1 billion times, it can, you know, take quite a lot of time. And then you need to test another password and so on. Okay, so at least this way of operating mitigates the possibility of having password cracked, even if the passwords, so the hashes of the passwords, are leaked. I mean, there are around. I mean, there's even a website where you can check if there is a password that corresponded to your username that has been leaked somewhere. I mean, typically your username is an email. You can look it up in the internet, and there are people maintaining the list of the emails for which password has been leaked, and we are probably, all of us are probably there. Okay, because it happens so often. Okay, and then we need to store the passwords on the server. And we will use a function, okay, a password hashing function. It generates a string, and in short, for us, we will only need to, you know, basically store strings, okay. Just don't forget for the exam. We will continue next time. I mean, you need to tell us which is the password because we only see the hashes from the database, okay. So in the README file. We will give instruction for this, but in the README file at the end, don't forget to say which are the usernames and the passwords. Username, we can see them in the database, but the passwords, I mean, if you only see hash the passwords, we have no way of knowing the passwords. Okay, so don't forget to tell us the password to test your web application. Okay, but you understood what's the problem, and we just scratched the surface of the problems that we have on the server for dealing with authentication. Password is just one of them. Okay, we'll say given the time, next time we will see the rest, how to use it in practice of the code, establish a session, and so on. Okay, there's quite a lot of things that we need to do. Okay, but you already have the slides. If you are curious, just have a look. We will finish them on Thursday, plus we will try to implement them in the code. Okay, so we prepare something, and we will do the most interesting part together during the lecture, as usual. Okay? Okay, if you have any questions, I can answer. Otherwise, we will meet tomorrow during the lab. Remember, it's room R3B and then 10I. Okay? Okay, I don't see any questions, so thank you for your attention, and we will meet Thursday for the lecture and tomorrow for the lab.